So, all right, transition math team. Let me start off with a quick review of what we've learned thus far in chapter 2, and that would be Rachir. Here we go. Again, this is the scan of the textbook. And what we learned is that we have these functions called exponential functions, where you have a base to some power x. And I wonder if this image gets any better if I blow it up. Yeah. No. I'm hoping it looks better on your device as you work through this. But at any rate, y equals b to the x. In fact, more commonly, we have been using y equals a b to the x power. And we were working with tables and graphing those things. We were working with the equations and graphing those, maybe making a table before graphing it. We also took on a gold note sheet that formula. That formula where it's the amount or final amount of stuff you get is based upon the principal or the initial amount, like if you do an investment, or the starting value of a car, is equal, or it times, so the final amount equals the starting amount times 1 plus or minus the rate as a decimal. As a decimal. 11% is 0.11. 8% is 0.08. Close the parentheses, all to the power of t. T is always in years. And what we did there is we did a plus if it was an investment, like buying real estate, buying stocks, buying bonds. It's a minus if you bought a house or a snowmobile or a four-wheeler or any of the fun things we want. They all depreciate. So minus if it's losing value, plus if it's gaining value. That's what we talked about, growth versus decay. And then we talked about particular examples, like here's one in the book where they're talking about a guitar. It was worth $12,000. It actually gains value at 14% a year. Oofta. So 1 plus 0.14, and that is the equation that gives us the value of that guitar over time. This thing, the 1 plus 0.14 or the 1.14, that is the multiplier. You'll see that that term more and more often. That is the base. The base of this thing taken to an exponent. Then there's this value, the value of a truck. It was bought for $28,000, so it's 1 minus. It only loses 9.5% per year. That's crap. It's a big, fat, hairy, fur-bearing lie. Vehicles lose more money than that, unless it's a special kind of truck with a really great engine. They asked the question, when will it equal $5,000? What we did in class is we guessed and checked. We put a value in for t and hit enter on the calculator. We put another value in for t and hit enter. That's one way to do it. Another way is to graph that sucker and then trace. And they're showing a graphing calculator. And at this moment, you might be thinking, OMG, I don't have a graphing calculator. I can't do anything! Forget this. And that's not true. As I said in my email, and as I'm about to show you right now, we have this thing called Desmos. And I'm actually going to show you this function graph. The value of this function is 28,000. And yeah, okay, here we go. When you get Desmos, the link I gave you sends you here. And you can click on Start Graphing. And here you go. And you type in the equation, and it graphs what you give them. And I just want to point out to you that if you download it into your smartphone, it actually looks a whole lot like this. I mean, it's really sweet. It's neat. It's clean. It does a nice job. So I click on this. Down here is the keyboard. And they told me the value of that truck was $28,000. And then times, and then it was losing value at 9.5%, 0.095, close the parenthesis, to the x power. Oopies, back that up, back it up, back it up, back it up. I have to take that to the x power. Notice I'm using parentheses here, the x that's here, that's squaring, and that's to the power. Now, it's not showing up because $28,000 is way up there. So what you gotta do sometimes is just be smarter than the technology. You can literally, on your phone or on this app, just grab it and drag it. The other thing is you've got these little plus minuses over here, and to zoom out, you just hit minus. And I'm just gonna keep zooming out until I see a graph that actually looks the way it ought to look. And the problem with this graph is that, you know, if you scroll way up here, you're gonna get to $28,000. The problem is that the horizontal grid, left and right, this much is the same as that much. In other words, this is 500 years. So you're gonna have to play with these graphs sometimes to get it to be the way you want it to be, kind of like this. I got one finger on the left holding still, I got another finger on the right stretching it out. I'm going to do it again. And now this makes more sense. Now you're probably not going to own a truck for 40 or 50 years. You might own it for 30. And then what you can do is the same thing here. You just, one hold still and the other one drag it down. And now this is more like the graph that you would want to graph. Here we go. This is the graph that we would probably put into our notebooks. So, the question in the book was, when's that thing going to equal $5,000? La, 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 la. Remember the trace button on the calculator? Your finger is the trace button. So it's a little over 17 years. Right up here, you can see where it started. Oh yeah, $28,000. It makes sense. That was the starting value. And again, you could trace. So 5 years from now, that truck is only going to be worth about $17,000. And then you could go down to 10 years from now, and you could just figure out what the value of this thing is. It's a useful device to solve any of your life problems, actually. Desmos. When I went to Desmos, I went ahead and I hit the star button, and it wants you to like leave the word Desmos in there. I don't leave, if you notice how many icons I have here, I don't keep the words there. I just keep the icon. Like, I know what our textbook is, Desmos, Skyward, our website, Amazon, Google, Netflix, YouTube. I don't need the word YouTube after the standard YouTube icon. Duh. Just a word to the wise. You can shrink up all that crap, get a lot more buttons on there if you just don't put the words in there. You can get rid of the equation, look at the graph more closely, get that equation back, get the keyboard back if you want to tweak any stuff. So, yeah, by the way, functions. Hey, do we have log? Stats, no log there. DIST, this is distributions, it's more statistic stuff. Miscellaneous, natural log, log base A. Yep, what we need for this chapter is all in here. It's in the functions button. Use it. Telling you, you are not out of luck, and don't call me to tell me that you couldn't do anything in our book. It's not right. Told you in the email, telling you in the video. Get on it. Get on it. Get Desmos on your phone too, though. Sweet. Now, the book homework that we did in class, right there. And there was some more, remember the review problems I had tossed in there. Here's the review problems. It's good to keep that stuff in there. And then we talked about inverses. And if you remember inverses, the whole main idea there was that your X and Y table trades. The X's and Y's trade. And it looks like this blue curve is reflected across this green dashed line. And the green dashed line is the line Y equals X. So no matter how kooky the graph is above there, it flips on the other side. If the graph is covering the Y equals X line, it's okay. It'll flip across that line. So what's above ends up below, what is below ends up above. That's how graphing an inverse works. That's how going from a table to the table of the inverse works. And then we have this funny notation. Yeah, it's up here. Right here. The f with the little -1 of x. I know the notation's not so great, but it's doable. Then we talked about, well, how do you find an inverse? Well, what we did, it's not shown this way in the book, but we put y where it says f of x, and there's the x, and then we traded the two, so there'd be y here, and then there was x there, and then we solved for y, which means we had to divide by 2. We trade the y and x, and then solve for y. That's how we got the inverse every time. They show it better in this example right here. There's the y and the x, and then you can see they traded the y and x. They just flipped it. Then they solved for y, and we had weird looking equations like this. Then they asked us to graph them. No big deal. It wasn't a big deal to graph them. Then we had some other fun equations to solve. You could study those as a review as we go forward. And then section 7.3 is what we did on Friday. So in 7.3, we talked about how to write an exponential equation in log form, and how to write take a log form equation and write it in exponential form. And if you remember, I did this thing where I circled the base, I went across the equal sign, and then back again to the exponent. So log base b of a is equal to x. Same thing going back the other way. Circle the base, go across the equal sign, and then back. So b to the x power is equal to a. It's this little swirl around that gets you the other equation pretty nicely. Rewind this video to help you remember, because that's what we did in class. We would go from exponential to log, log to exponential. That wasn't so bad. We did a bunch of that. They have properties here, and I'm going to get to properties in the next video for the next lesson, but that's where we left off. That was the homework for 7.3. If for some strange reason you didn't get that done, that's okay, get it done now. But get on it, stay on top of this. That's where we left off before we were told we could not see each other again.